I'd like for you to do now is to, again, take a look at this slide. This is sort of a practice slide. I want to point out before you move on your notes, this originally said CO2. I thought I had changed it. I forgot. It's a typo. Scratch it out. It's just CO. It's just carbon monoxide. Okay, so you want to make that little correction on your PowerPoint slides. All right, so what I'd like for you to do is go ahead and pause the video at this point and make sure you can look at each one of these reactions and identify, you know, what's undergoing oxidation, what's undergoing reduction, and what you would call the oxidizing agent and what you call the reducing agent, okay, for each one of these. So go ahead and turn off the video, or just pause it, and work in small groups. You should have recognized this is an oxidation reduction reaction, and that the oxidation numbers are changing from 0 to +2 in this case, and to -1 in that case. You should recognize that the magnesium is undergoing oxidation. Okay. And the chlorine is undergoing reduction because it's gaining electrons from a 0 to a -1 oxidation number. Okay, reduction. Therefore, this is the reducing agent and this is the oxidizing agent. Again, for this one, you should go through and you ought to be able to very quickly label the oxidation states all the way across. This should become just very easy for you. Hopefully you were able to do that. Then you can recognize that the bromide ion going to bromine is what has undergone oxidation, and the chlorine is reduced because it has gained an electron. Okay, and then the next one down, -2. Okay, again, remember this is carbon monoxide, not carbon dioxide. Oxygen is always -2, so in this case the carbon is +2. Here this is elemental iron. Here you've got -2 for the oxygen and +4 for the carbon in this case, and the carbon dioxide. All right, and so you look again to see where the oxidation numbers are changing. The oxygen isn't changing, but the iron and the carbon are. So the iron is going from a +3 to a 0. So it must be gaining electrons since it's going from a higher number to a lower number. So that's reduction. And the carbon is going from a +2 to a +4. It's getting a higher oxidation number. It must have lost electrons. Oops, so that's oxidation loss. Alrighty, and then this is the oxidation agent. This is the reducing agent. Okay, now for this one, go across and label your oxidation numbers. You have +1, -1, +1. Of course, this is nitrate. It's going to be -2, and the nitrogen is going to be +5. +1, -1, +1, -2, and +5. Okay, take a look now. Where has the oxidation numbers changed? Well, the sodium, no. The chloride ion, no. The silver ion, no. The nitrogen, no. The oxygen, no. So in this case, this is an example of a chemical reaction that is not an oxidation reduction reaction. This particular reaction is, there's no change in oxidation numbers, so it's not a redox reaction. Not all chemical changes are redox reactions, and this is an example of one that is not. Electron transfer is not occurring. Okay, there's no electron transfer here. In this case, it's just a switching, what we call is kind of a double replacement or switching of partners, and there's no oxidation or reduction, and we end up with what we call a precipitation reaction. Okay, so you don't always have oxidation and reduction going on.